Hi everyone, and welcome back to another episode of Dr. Kyle Explains, your YouTube channel where we go through GCSE science content quickly and easily. Today we're going to be going over nanoparticles. Now, some of you may notice this is a rerun of a previous episode, as we had a few editing issues with the last one, so we're just going to make sure this one goes through nice and cleanly. Thank you for the comments letting me know, and please do give the video a thumbs up, subscribe to the channel, grab a pen and paper, and let's go ahead and jump in. Okay, so some key content first of all. Nanoscience refers to particles that are between 1 and 100 nanometers in size. Now, nanoparticles are smaller than fine particles, so fine particles are known as PM 2.5, so that's particulate matter 2.5, and coarse particles are known as PM 10, so particulate matter 10, and these are often referred to as dust. So essentially there's two types of particles, fine particles and dust, and then we have nanoparticles that are smaller than both. We'll go over that in a little bit more detail on the next slide. So nano is 1 billion times smaller than a meter, and your fingernails grew roughly about 1 nanometer after you just read that sentence. So just to give you a perspective of how small a nanometer is. Okay, so looking at this table then, hopefully we can see we've filled out some of the key information between nanoparticles, particulate matter 2.5 or fine particles, and coarse particles. Now the take-home message here is that because nanoparticles are so small, that means that they can be absorbed into the blood. And so a potential disadvantage of nanoparticles is that we have unknown health effects or potential unknown side effects because they can get into our body and into our bloodstream. Now, particle matters of 2.5, or particulate matter is 2.5, they can cause health problems because they're small enough to be breathed in, but they're too big to get into the bloodstream. So they essentially get stuck in the lungs. So an example of this could be something like asbestos that you might have heard of before. It can be quite dangerous when you breathe it in. And then coarse particles are essentially just normal dust. And obviously, if you ever go into a dusty room, like a loft or an attic or a shed maybe, sometimes you might cough a bit and sneeze because all of that dust is irritating your lungs. But the good thing about that is because it's large enough, your body can get rid of it. So the smaller the particle is, the potential more hazardous it is. If it's particulate 2.5, then it can get stuck in your lungs and that can cause long-lasting health problems. And then the nanoparticles, they can actually be absorbed into the body and into the bloodstream. Okay, so some uses of nanoparticles then. Now, I'd really recommend you just have a quick YouTube and search on YouTube. Just type in uses of nanoparticles, and there are some amazing applications for nanoscience. So just have a look, see some of the useful applications on YouTube. So nanoparticles have many applications, including medicines, in electronics, cosmetics, sun creams, deodorants, and catalysts. Remember, a catalyst speeds up a reaction. New applications for nanoparticles are a really important area of research. Now, you do need to know all of these applications, and you have to know that nanoscience is a potential area of research in the future. So in this table, what I've done is I've just kind of summarized each section that we've just looked at here. So we've got electronics, and so if we're using nanoparticles, it's the whole idea that it could make it lighter weight and it will make it more efficient. And so your mobile phone might become lighter in weight and the battery might be able to last longer because the electronics have become much smaller, so the electricity doesn't have to travel as far, so making it more efficient. Cosmetics, sun creams and deodorants, I'd probably kind of class all together, but it's that whole idea that you could use less. So if you're using less makeup, if you're using less sun cream, if you're using less deodorant, that's obviously going to be better for the planet because we're not wasting as much. So because it's smaller, we're using less amounts. Now remember, the issue with this is potentially they could get into the bloodstream and potentially cause unknown health effects. Catalysts, they have a higher surface area for reactions, so you can use, again, less in the reaction, saving money and energy again. And then medicine, it actually has an important role as potential drug delivery systems. So because they can get into the blood, it means that we might be able to wrap drugs inside of these nanoparticles and target exactly where we want it to get to. So some really interesting applications here. Now, these are specific applications that are on the specification that you do need to learn for your GCSE. Okay, so why do particles have such different properties to normal particles then? So nanoparticles have different properties from those of the same properties in bulk because they have a high surface area to volume ratio. So if you have a question that said, why do nanoparticles have different properties, or why do silver nanoparticles behave different to larger silver particles? It's because they have a high surface area to volume ratio. So this often means smaller quantities are needed in order to have the same effect of normal sized particles. Okay, so it's really important to be able to work this out. Now, this could actually be in biology, chemistry, or physics. I've seen it come in multiple different exams. And this is how to work out the surface area to volume ratio of a cube. Now, specifically for nanoparticles, we need to know that as the size of the cube decreases by a factor of 10, the surface area to volume ratio increases by a factor of 10. So looking at this 1 centimeter cubed here, hopefully we know that each cube has 6 faces. And so 1 centimeter cubed, it means we have a surface area. So we're going to do length times width to get the area of that first square. And then we're going to times it by 6 to get 6 centimeters squared. Now volume is obviously length times width times height. And so we're going to do 1 times 1 times 1 to get a 1 centimeter cubed in volume. Now when you divide one by the other, you then get a ratio of 6 to 1. And so what this means is for every 1 centimeter cubed, hopefully we can realize we have got 6, 1, 2, 3, 4, 5, and then one on the other side, 6, bottom there, 1, 2, 3, 4, 5, 6. Hopefully you realize that for every 1 centimeter cube, you have 6 faces. And so therefore there are 6 centimeters cubed of surface area to volume ratio available. Now, when you do the same calculation on a 10 centimeter cubed, so 10 times 10 times 6 is 600 centimeters cubed, and then to get your volume, 10 times 10 times 10 is 1,000, it works out when you divide one by the other to 0.6 to 1. And so can we see, as the size of the cube decreases by a factor of 10, the surface area to volume ratio has increased by a factor of 10. And that means that you have these special properties forming for these nanoparticles. I would really recommend you understand how to work out the surface area, the volume, and the surface area to volume ratio for your GCSEs, as I've seen this come up multiple times in previous exams. Okay, so today what we've gone through then is we've defined nanoscience, we've listed advantages and disadvantages, and we've given some uses. And then we've described how the surface area to volume ratio increases as particle size decreases. Thank you very much for watching. Please do go through my other playlists for more GCSE science content. And remember, if you ever need help with your GCSE science, Dr. Kyle explains. Thanks very much. Bye-bye.